Have you ever pondered about the size of the largest stars in the universe compared to our own sun? The universe, in its majestic vastness, is home to an unimaginable number of celestial bodies, each varying in size and characteristics. To grasp the scale of these cosmic entities, let's begin with something a bit closer to home: Jupiter, the largest planet in our solar system. Known as the giant planet, Jupiter's mass is a staggering 317 times that of Earth. If you picture Earth as the size of a grape, Jupiter would be the size of a basketball. That's quite a leap, isn't it? But wait, there's more. Jupiter's diameter is about 11 times that of Earth, making it a behemoth in our planetary neighborhood. It's mind-boggling to imagine, isn't it? A world so massive that it could swallow Earth and still have room for over 1,000 more. Yet, despite its colossal size, Jupiter's day lasts only about 9.5 Earth hours, the shortest of all the planets. This rapid rotation causes the planet to bulge at its equator, making it more of an oblate spheroid than a perfect sphere. But let's not get too caught up in Jupiter's grandeur. After all, we're here to talk about stars, and compared to them, even our giant planet appears quite humble. Keep in mind, Jupiter is just a planet, not a star. It doesn't have its own light, but reflects the sun's light. By now we've given you a sense of scale, starting from our home planet Earth, jumping to our solar system's largest planet, Jupiter. But as we venture further into the cosmos, these measurements will seem minuscule. So buckle up, as we are about to embark on a journey that takes us to the heart of the universe, where celestial giants dwell. When we talk about stars, however, Jupiter is just a speck in the grand scheme. So as we move forward, let's remember our humble beginnings and brace ourselves for the mind-boggling scales that lie ahead in our cosmic journey. What if we told you that there are celestial bodies that bridge the gap between planets and stars? Let's embark on a journey to explore these intriguing objects known as brown dwarfs. These cosmic entities are somewhere between the mass of a planet and a star, not quite fitting into either category. For instance, let's consider Gliese 229b. This fascinating brown dwarf is around 40 times the mass of Jupiter, our solar system's largest planet. You might think, that's enormous. Well, in the grand scheme of the universe, it's actually quite modest. The intriguing part is that despite its mass, Gliese 229b doesn't quite make the cut as a star. Why, you ask? It's because stars, unlike brown dwarfs, can sustain nuclear fusion in their cores. Gliese 229b, with all its mass, cannot. While impressive, Gliese 229b pales in comparison to true stars. Now let's get acquainted with the real stars. In the starry sky above, there are countless celestial bodies, each with their own unique characteristics and stories. Among them, red dwarfs like Barnard's star hold a special place. Despite being smaller and cooler than most stars, red dwarfs are the most numerous type of star in the Milky Way. They may not be as flashy or visible as their larger counterparts, but they definitely win when it comes to longevity. You see, red dwarfs use their fuel very sparingly. Their slow fusion rate allows them to burn for an incredibly long time. We're talking about trillions of years, which makes the human lifespan feel like the blink of an eye. That's right, trillions. These little stars are the true marathon runners of the universe, outliving even galaxies themselves. Now let's bring it closer to home. Our sun, the star we're most familiar with, is actually a medium-sized star. It's like the Goldilocks of stars, not too big, not too small, just right. At least just right for us and our planet Earth. But compared to red dwarfs, our sun is a bit of a sprinter. The sun is about halfway through its life, which is estimated to be about 10 billion years. Yes, that's billion with a B. It's been shining for about 5 billion years, and it's expected to keep on shining for another 5 billion. But remember, compared to the trillions of years that a red dwarf can live, our sun's lifespan seems rather fleeting. So, while the sun might appear to be the most important star from our vantage point here on Earth, it's worth remembering that it's just an average-sized star in our galaxy. There's a whole universe of stars out there, each one as fascinating and unique as the next. Our sun, as familiar as it is just an average-sized star in our galaxy. If you think our sun is large, wait till you meet its bigger cousins. Now let's venture beyond the familiar warmth of our sun into the realm of larger stars. Picture Sirius, the brightest star visible from Earth. It's not just its radiance that's impressive. Sirius is twice as massive as our sun and 25 times more luminous. It's like a supercharged version of our sun, gleaming brightly in the night sky. Yet, our cosmic journey of scale doesn't stop there. Let's crank up the size dial and introduce you to Betelgeuse, a red supergiant located in the constellation Orion. This stellar behemoth is about 1,000 times the diameter of our sun. If you were to replace our sun with Betelgeuse, it would engulf all the planets up to Mars. Quite a size leap, wouldn't you say? But Betelgeuse isn't just about size. It's also a shining example of a supergiant star, the stage in a star's life cycle when it has exhausted the hydrogen in its core and expanded dramatically. As a red supergiant, Betelgeuse is nearing the end of its life, and when it finally runs out of fuel, it will explode in a spectacular supernova. That's a light show we wouldn't want to miss. Betelgeuse also stands out for its variability in brightness. It dims and brightens irregularly, a behavior that has led astronomers to speculate that it might be on the verge of going supernova. However, these fluctuations are better explained by cycles of heating and cooling in its outer layers. So, while Betelgeuse will certainly go supernova one day, it's unlikely to be in our lifetimes. We talked about Sirius and Betelgeuse, stars that dwarf our sun in size and luminosity. But remember, the universe is a vast place, and there are stars out there that make even Betelgeuse seem small. Betelgeuse, as gigantic as it is, isn't the largest star we know. But who holds that title? Stay tuned and we'll reveal the champion in our next scene. Meet Scuti, the largest known star by radius. This celestial behemoth dwarfs our humble sun to an almost unimaginable degree. Picture a sphere so massive, so incredibly vast, that it is roughly 1,700 times the size of our sun. Now that's a sight to behold, isn't it? It's a concept that's almost too enormous for our minds to fully grasp, but let's try to break it down. If we were to replace our sun with Scuti, this behemoth wouldn't just take up the space that the sun occupies. No, it wouldn't stop there. It would extend well beyond the orbit of Mercury, Venus, Earth, Mars, and even the large gas giant Jupiter. That's right, its outer layers would reach out into the cold void, extending beyond Jupiter's orbit. Now that's not just a star, that's a titan of the cosmos, a true giant in a universe of giants. Scuti is a red supergiant star located in the constellation Scutum. And it's not just its size that makes it stand out. This star also has a luminosity approximately 340,000 times that of our sun. Imagine the light from that many suns, all emanating from one single point in the cosmos. It's awe-inspiring and humbling, to say the least. We've journeyed from the familiar grounds of our own solar system, through the realm of brown and red dwarfs, past stars like our sun and the luminous Sirius, to the red supergiant Betelgeuse, and now we stand before the grandeur of Scuti. As we gaze upon this celestial titan, we are reminded of the vastness of our universe and our place within it. Scuti shows us how vast the universe is and how small we truly are. It's a humbling perspective, isn't it? But remember, as vast as the universe is, it's filled with wonders like Scuti, waiting to be discovered and understood. Our journey into the cosmos is just beginning. The universe is vast, and the continual discovery of new stars suggests there's much more to uncover. From the comparison of Jupiter, our solar system's giant, to the mind-boggling scale of Scuti, we've journeyed across the cosmic spectrum of size and mass. We've dipped our toes into the celestial pool of brown dwarfs, warmed ourselves by the familiar light of red dwarfs, and marveled at the luminous grandeur of supergiants. And yet, this is merely a snapshot of the universe's infinite canvas. Consider this. If our understanding of the universe has allowed us to identify a star as colossal as Scuti, imagine what cosmic giants may yet lurk undiscovered in the uncharted territories of the cosmos. So as we continue this journey, remember that the universe's grand design is ever evolving, always ready to astound us with its scale and majesty. Join us again as we continue to unravel the mysteries of the cosmos. Goodbye, and keep looking up.